Alright, hello guys. We're going to take a look at the special triangle, which is a 30, 60, 90 degree triangle. Um, and so there's basically two special triangles that we study in geometry, and we use them also in trigonometry, which is what we're going to use this for. There's nothing you couldn't do with the Pythagorean Theorem with this stuff. And frankly, I think the Pythagorean Theorem is more helpful. But there's just some special relationships here that make these triangles convenient to work with, and we'll definitely use them when we start looking at the unit circle. And so let's take a look at what goes on with the 30, 60, 90. Let's just say, for example, that this small leg, so that the smallest leg of this triangle, the right triangle, let's just say that that's 1 unit. Okay, so that's 1 unit right there. And so then can I find out what is this other leg and what is the hypotenuse if I only know that this is 1? And I could make some variables and run Pythagorean theorem with variables, but that's not really what I'm after here. I want to find an actual relationship. And so what I'm going to do is I'm going to go ahead and duplicate that triangle and use some symmetry to show you the relationships between the sides. So what I've done is I've essentially cloned that yellow triangle and flipped it and stuck it to the other side to make what I have here now is an equilateral triangle, in which case all the sides are the same length, because right here 30 and 30 together make 60. And so if all the angles are 60, 60, 60, then all the sides are the same length. Okay, and now if this is 1 unit, well, if I duplicated that, this unit will also be 1. And if I put 1 and 1 together, then this whole bottom leg of the bigger triangle between the white and yellow is 2. Okay, and what that allows me to show then is that since it's equilateral, then this is 2 as well. And so what I have now is I have shown that in every 30, 60, 90 triangle, the hypotenuse, which is always opposite of the 90-degree angle, the hypotenuse is twice as long as the shortest leg. Okay, so now what about the longer leg? What about the side that's opposite of the 60-degree angle? What is the length there? And so here I can use my trusty Pythagorean theorem, and I can go ahead and solve for that missing leg. Let's just call it b. So say we have 1 squared plus b squared is equal to 2 squared. And so then I go through, square those, set b squared by itself, and this is going to be 4, that's 1. Subtract 1 from 4 and you're going to get 3. And so b squared is equal to 3, and we've solved enough quadratic equations to know that if I take the square root of both sides, I will have my value for b. So the question mark here, the long leg, is going to be the square root of 3. So I'm going to replace that with the square root of 3. And so what I just did was basically show the relationship between the 3 sides of a 30, 60, 90 degree triangle. Let's go ahead and clean this up a bit because there's a lot of junk in the way. So let me just get rid of some things. Get rid of that, that, and that. And let's also go ahead and get rid of this for a second. So now what we know is that in this 30, 60, 90 triangle, the short side and the hypotenuse are always related in a 2 to 1 ratio. So whatever this is, the hypotenuse is double. Now whatever the short side is compared to the long leg, the short leg to long leg, the long leg is always root 3 times the short leg. So if this is 1, this is going to be 1 times the square root of 3. So that will come in handy when we start studying the unit circle, and those values will become pretty familiar to you. Let's jump down and take a look at the other special triangle, which is a 45, 45, 90 degree triangle. And you know what's mostly special about this is that each leg, of course, is congruent because they have opposite angles that are the same. And so if it's an isosceles triangle, these two legs are both congruent. So let's say that just for the sake of ease, let's say that they are 1. So this is, let's say, 1 unit. This over here would then be 1 unit. And what is the hypotenuse? Well, what's our most famous, most useful right triangle tool? Pythagorean Theorem. Let's use that, and let's square both of those sides and solve for the hypotenuse. So if I solve for c, in this case, c squared is going to be equal to 2. And so then square root both sides, you get c is equal to the square root of 2. So this would be 1 times square root of 2. So what I've shown here is that in every single 45, 45, 90, whatever the leg is, the hypotenuse is going to be root 2 times that value of that leg. So those are the two special triangles, and let's go ahead and just take a look at just working on some repetition with some actual values in place. Okay, the first value we will reiterate would just be any generic value. So let's just say we have any generic value. Let's go with x. So if the short side is x, what that means is the next easiest side defined in the special triangle would be the hypotenuse side. And the relationship there was that the short side and the hypotenuse were always double. So if this is x, any number, this is going to be 2 times that number. Okay? The other relationship between this is if this short side is x, the long side is always root 3 times that value or that number x. And so this is how the 30, 60, 90 is related. I would refer back to this page as you're maybe doing some of the homework problems. Same thing over here with the 45, 45, 90. If this side is x, any number x, of course, what is this side going to be? Also x, because it's isosceles triangle. And then we remember we just discovered that this side was going to be always root 2 times whatever that leg is. And remember, how did we find that? How did we figure that all out? We used Pythagorean Theorem. And with the 30, 60, 90, we used a little symmetry and Pythagorean Theorem. So let's now take a look at some examples. Let's just say, this is probably the easiest scenario. Let's say that the short leg of a 30, 60, 90 is 4. Oops, I don't know what that is. Let's say the short leg of a 30, 60, 90 is 4. Okay? What is the hypotenuse going to be then? Remember the relationship was double, so the hypotenuse is then going to be 8. And what is the longer leg going to be? 4 root 3. And you'll just become familiar with those values and those relationships. All right, let's change it up a little bit. Let's say we know the hypotenuse. Let's say we know the hypotenuse is, I don't know, 16. Okay, now if we're working backwards, we know the hypotenuse is 16. So then the short leg is the next easiest one to find, and that's always half of the hypotenuse because we're going backwards now, so that's 8. And then the longer leg is root 3 times the shorter leg, so that would be 8 square root 3. So that would be another scenario of having to work that out. And you know the relationships, so you should be able to crank those out. The other scenario, well, you might run into this. This kind of throws people off a little bit. What if this short leg here was, I don't know, 4 root 2. Okay. Well, now you add a radical in there, and it's an exact value radical form, and people kind of get a little goofed up here. But what is 2 times 4 square root 2? Well, that's just 8 square root 2. You just leave them in radical form. We're going to be working with radicals for a while. Now, to go from the short leg, so to go from here to here, remember what did we have to do? We had to multiply by, oops, I was going to write a root 2. We have to multiply by regular 2. No, that's kind of goofy. To go from the short leg to the hypotenuse, goodness, oh boy. Let's see if I can do this without screwing anything up here. WQ. Alright, I'm going to pause it and get this sorted out here in a minute. Alright, so let's try this again. So if to go from the short leg to the hypotenuse, so if I go from there to there that way, I'm going to multiply by 2. Whatever it is, I multiply it by 2. Okay? If I go from the short leg to the long leg, I'm going to multiply that by square root of 3. So what do I get when I multiply 4 square root 2 times square root 3? And so those of you who have practiced your radicals and are proficient with multiplying radicals know that that's just going to be 4 times the square root of 6. And you can't really simplify that any further, so you just leave it in radical form. So some people get goofed up when you have to multiply with radicals in there. But, you know, just do what you did when you were simplifying the radicals and just work with them in radical form. Probably the trickiest part would be if I know the long leg. Let's just say I know the long leg is like 9. Okay? If I know the long leg is 9, how do I work backwards from the long leg? So how do I go from the long leg to the short leg? Well, the inverse of multiply, because if I go from the short leg to the long leg, I multiply by root 3. So in this case, I'm not going to multiply by root 3. I'm going to divide by root 3. Okay? So if I divide by root 3, then over here, this ends up being 9 divided by square root 3. But, oh, we have a radical in our denominator. Oh my goodness. Can never have that. So we better rationalize it for all those old school mathematicians out there. And we do that by multiplying by root 3 over root 3. And so we're going to end up with 9 root 3 over 3, which ends up being just 3 root 3. And I guess I better be a thorough math teacher and show you how that all works. So we have 9 divided by root 3. We're going to rationalize, multiply by our fancy looking 1, which is really just a root 3 over root 3. And that's going to give us 9 root 3 over root 3 times 3 is 3. And then I have factors of 3 in my numerator and denominator, and so I can take out a factor of 3 there, which leaves this as 3 square root 3. Now to go from the short leg to the hypotenuse, I need to multiply by 2. So 3 root 3 times 2 is 6 root 3. You know, and that's probably the most non-intuitive scenario, to have to divide by root 3. Okay, so we started out with 9, we divided that by root 3 and got to there, and that was a short leg, and then I multiplied by 2 to go there. So those are some scenarios that you'll run into with the 30, 60, 90. The 45, 45, 90 isn't quite as confusing because you only really have one relationship, and that's root 2. So let's say this side is 3. Well, then we know this side is 3, and this side is 3 square root 2. Pretty straightforward. What if we know the hypotenuse? Let's say we know the hypotenuse is, I don't know, 6. Then to go from there backwards, I got to divide by root 2. So 6 divided by root 2 gets us to our dreaded radical in the denominator. But we're getting good at rationalizing these. And so we're going to have 6 root 2 over 2, which reduces to 3 root 2. Okay, so then you have your 3 root 2. And it's a good idea to maybe just stop here and just think about, okay, well, if I have 3 root 2 and I multiply that by root 2, am I going to get to 6? Just kind of checking our work. Is 3 root 2 times root 2 again going to get us to 6? And this is a good opportunity for me to point out the fact that if you ever have a root 2 times a root 2 or any radical times itself or squared, that's going to get rid of the radical part itself. So this is going to be then 3 times 2, which is in fact, holy buckets, that was horrible. I'm working on this different pad because I'm at home here, and this is not as easy as a smartboard, but it is in fact that right there. Bada bing. Okay, so there's another scenario. Maybe let's do one more scenario with the 45, 45, 90, and then we'll wrap this up. So we have here, let's say, I don't know, let's say this is 4 root 5. Okay, remember, don't get scared here. It's just a radical in there, no big deal. This other one here is also 4 root 5. Okay, and then how do I go from the short leg to the hypotenuse in this situation? I multiply by root 2. So 4 root 5 times root 2 is 4 root 10. And there's nothing inside of the radical that I can simplify, so I just leave it as is. Okay, so there are the special triangles, and some of you might be wondering, hey, what's going on at home? How's the baby? Because the reason I'm making this video is because I'm home because we have a new baby. So we do have a new baby. The baby and mom got home today, so home from the hospital. Everyone's good, and Mr. Arlo Bolio is sleeping right now. So hopefully you watched this and you learned what you needed to learn. So work hard. We'll see you next week.